Okay, in this video we're going to talk about Unit 2, Objective 10, which is implicit differentiation. Implicit differentiation is a way to take the derivative of a function that's not defined in the way that we usually see it. Usually we see functions like y equals 3x squared plus 5x, and this is called an explicit function because it's written explicitly y in terms of x. So one variable equals something with one variable. So one variable on each side. And the derivative of this is very easy, right? dy over dx equals 6x plus 5. Now the reason I wanted to point out this easy derivative is because of that dy dx. So what we mean when we say dy dx is the derivative of y with respect to x. And all that means is y is my function that I'm taking the derivative of, and x is the variable within that function. So what you see on the screen right now is actually implicit differentiation, but we don't really think about it as implicit differentiation. If you think about what we did with our dy dx, we could do the same thing with an x. We could say that we took the derivative of x with respect to x, and we're left with dx over dx, and dx divided by dx would just be 1. So we are not ever going to, and we haven't up until this point, we're not going to write a dx over dx. But it's really there. We've been doing it this whole time. So the reason I'm pointing that out is implicit differentiation is how we differentiate implicit functions. So a function that might be written like 3y squared plus 7 equals 5x plus 2. So we don't have just y equals like we're used to having. Now you could, if you wanted to, subtract this 7, divide by 3, take the square root, and then you have an explicitly defined function like we're used to. But that's a whole lot of work when an implicit differentiation isn't really that difficult. So implicit differentiation is the same idea, the same concepts, the same rules as explicit differentiation. We just have to think about writing our dy dx like we have before. So if we look at 3y squared, and I said just take the derivative of 3y squared, you would probably tell me 6y. If I told you to take the derivative of that 7, you would tell me it's 0. And then if I said take the derivative of 5x plus 2, you would tell me the derivative of 5x plus 2 is 5. Now you'll notice I left a blank right here. This is why we talked about on that previous slide this dy dx. You took the derivative of y and you told me you did so by saying dy dx. So the only thing that's different with implicit differentiation is you have more than just y. In this case you have 3y squared. But if you took the derivative of that y, you need to tell me you took the derivative of the y by putting a dy dx on there. Now we just have one more step to go because I want to know what the derivative is. I want to know what the slope of that curve is. And right now I don't know. I know 6y times the derivative equals 5. I need to know what the derivative actually is. So we need to solve for that dy dx. So dy dx is going to be equal to 5 over 6y. So if you were to graph the relationship that we have up here, so if you move everything to one side, and if you were to graph that function, the derivative, the slope, would be defined by that right there. So on the surface, implicit differentiation is not that bad. However, AP is never going to be nice and give you a problem that is that easy. Almost every implicit differentiation problem that AP is going to give you is going to have product rule. And the product rule, let's go ahead and put a problem up here. 3y squared plus 5xy minus x to the third equals 7. The product rule is going to kind of be the difficult one to find, but it happens almost every time. The reason product rule is going to be difficult is because we're used to trying to find an x times an x. Well, in this case, we have two variables, x and y, so that middle term we have product rule. So what we want to do is just go piece by piece, term by term, like we usually would. So the derivative of 3y squared is going to be 6y. And then don't forget you took the derivative of y, so you have to tell me dy dx. Then we have our product rule. So the derivative of the first, the derivative of 5x is just 5. Keep the second the same. Plus, keep the first the same. Take the derivative of y. The derivative of y is 1. But then you have to tell me dy dx. So every time you take the derivative of a y, you have to tell us. And then the derivative of x to the third is 3x squared equals. Now here's a spot where you're going to potentially make a mistake. A lot of people are just going to drop the 7 down, but you have to take the derivative of the right hand side as well. So the derivative of 7 is 0. Now, the whole point of trying to differentiate implicitly is to find out what dy dx is, right? Like we did over here, we needed to get the dy dx by itself. So we need to do the same thing on this problem. We need to get the dy dx's by themselves. So everything that's not a dy dx, we're going to move to the other side. So we're going to subtract our 5y. We're going to add our 3x squared to both sides. And we're going to be left with 6y dy dx plus 5x dy dx equals 3x squared minus 5y. Now the last thing that we need to do is factor out that dy dx, right? We have a dy dx in each term, and we're trying to get that by itself, so we're going to factor out a dy dx. So we have dy dx times 6y plus 5x equals 3x squared minus 5y. To get dy dx by itself, we're going to divide by 6y plus 5x. So our derivative dy over dx is equal to 3x squared minus 5y over 6y plus 5x. So that is your run-of-the-mill implicit differentiation problem. This is how you're more than likely going to see it on AP. They might say, what is the slope of that curve at the point? So we'll say, what is dy dx at the point, and we'll just say 1, 2. So all you would have to do is take that point 1, 2 and plug it in. So we would say 3 times 1 squared minus 5 times 2 over 6 times 2 plus 5 times 1. So we get 3 minus 10 over 11. So negative 7/11 would be the slope at the point 1, 2. So that'll do it for this video. Again, the big thing to watch out for is your product rule with your implicit differentiation.